Good day everyone. Today we will be discussing about the fixed point method. On the first part, we will be discussing how to use the fixed point method and how to find the root of a certain equation using the fixed point method. On the second part, we will be showing and explaining the code that we were able to come up and use it to find a root of a certain equation. Fixed point method is a numerical technique used to find approximate solution to an equation. This involves iterative calculations rather than direct algebraic manipulations. So the goal of fixed point method is to approximate the root of an equation. In the context of numerical methods, the root is the value of the variable that makes the equation equals to 0. So we are used to finding roots either through the quadratic formula or using the factoring method. In factoring method, we factor an equation and equate its factors to 0. So it actually makes sense because just like in the fixed point method, we also equate it to 0. So the root is still the value that makes the equation equal to 0. As per its root, fixed point method only approximate root and not give the exact or specific value of the root, unlike other methods like the quadratic equation or the factoring method, which actually provide the exact root. Since in fixed point method, we actually substitute values to a certain equation. And if it results to a certain value, if it converges to a certain value, then we can be sure or we can conclude that the equation has that root or it's the root of the equation. However, in some cases, the results when we substitute certain values to an equation may not converge to a certain value. It's either because it isn't the root of an equation or the equation does not have any root, or we were able to reformulate the equation in terms of x wrongly. So fixed point method, as what I've said earlier, is an iterative approach where an initial guess is repeatedly refined to converge towards the root of the equation. The iteration is based on a fixed point iteration formula in the form x sub n plus 1 equals g of x sub n, where g of x is a function chosen such that the fixed points of g coincide with the roots of f of x equals 0. As what I've said earlier, in fixed point method, we substitute values to a certain equation. However, we just don't automatically substitute certain values to a certain equation. We need to reformulate the equation in terms of x. So when using the fixed point method, the first step is to take the original equation, which typically looks like f of x equals 0, and rearrange it to isolate the variable x on one side of the equation. This involves performing algebraic manipulations to express x as a function of itself. So before we move forward to the solving proper, we should first define several terms. So first is the initial guess. Initial guess is the starting point of an iterative numerical method. When solving an equation or optimization problem iteratively, you begin with an initial estimate or guess for the solution. Iterations. Iterations refer to the repeated applications of a mathematical process in the context of numerical methods, including iterative methods like the fixed point method or Newton's method. Each step in the process is called an iteration. Third is convergence. Convergence is a property of an iterative method by which the sequence of iterates approaches a stable or fixed value, often the solution to the problem. In the context of solving equations, convergence means that as you perform more iterations, the values you obtain get closer and closer to the true solution. Divergence, on the other hand, is the opposite of convergence. If an iterative process diverges, it means that the sequence of iterates does not approach a stable value or solution. Instead, the values may become increasingly distant from each other or oscillate without setting. So, in fixed point method, we can be able to quantify the difference between the successive iterations in the iterative process through the convergence analysis. The error at each iteration is a measure of how much the solution has changed from the previous iteration and is often used as a criterion for determining when to stop the iterations. So, the error formula is actually error sub n plus 1 equal the absolute value of x sub n plus 1 minus x sub n. Here, x sub n plus 1 is the value of the variable at the n plus 1th iteration, and x sub n is a value at the nth iteration. The absolute value is used to ensure that the error is positive regardless of whether x sub n plus 1 is greater or smaller than x sub n. So, in order for us to determine whether the value is actually converging to a certain value, the error should be less than the epsilon or the level of precision. If the error is greater than the epsilon or level of precision, then we can conclude that the values that we substitute are diverging or will never come up to a certain value, or it could come up to a certain value but kulang pa. So, how do we do fixed point method? So first, we need to start with an initial guess denoted as x sub 0. Apply the function f of x to the initial guess to calculate the next approximation denoted as x sub 1. Repeat the process iteratively using the result of the previous iteration to compute the next approximation. Continue the iterations until a satisfactory approximation of the fixed point is achieved or a predefined stopping criterion is met. So for the first and only example that we have the equation x squared minus x minus 1 equals 0. So when we reformulate the equation in terms of x, we can actually come up with 3 new equations. First is x equals 1 over x minus 1. The second one is x equals 1 plus 1 over x. And the third is x equals x squared minus 1. So in the following slides, we will be showing the solution of the 3 new equations, how we were able to solve the roots, the explanation whether they converges or diverges, and the method that we used in coming up with the roots. So in this slide, it actually shows 2 graphs that shows convergence and divergence. So in the first one, it shows convergence since as we substitute values to the equation given, it actually come up to a certain value. So in Tagalog, meron silang pinapuntahan na value. On the second one, as we substitute values to the equation, kay nagapalayo sila sa actual root. So, it shows divergence since it doesn't come up to a certain value. It doesn't converge to a certain value.
Hashtag include stdio.h is for input and output functions, while hashtag include math.h is for mathematical operations. F of x is used to find the root of your function. For example, we have x times x minus 8 times x plus 15. This is our function that we want to look the root for. While double g of double x is the fixed point iteration x minus g of x, which is 8 minus 15 over x. While the void fixed point iteration, this is the main function for our fixed point iteration. This contains three parameters. We have the initial guess, which is the initial value to start the iteration. We have epsilon, the desired accuracy, the max iterations, the maximum number of iterations to perform. Next is the fixed point function. We have double XO is the initial guess. It initializes the current guess as initial guess, while double X1 is declared a variable to store the next iteration value. The while loop iterates until the maximum number of iterations is reached, or the difference between consecutive x values, which is x1 and x0, is less than the epsilon. X minus 1 is equal to g of x0. This is updating the x1 using the g of x function, while the iteration plus plus increments the iteration counter. While the printf iteration %d is x is equal to %lf, it prints the current iterations and x values. Next is the checking of absolute difference between x1 minus x0 should be less than the epsilon. If it is, print approximate root %lf and return the function. But if the loop exits without converging, it would print a message, fixed point iteration did not converge within the maximum number of iteration. Next is the main function. This is First is to set your initial guess to 1.0 and your desired accuracy to 0.0001. But this can be adjusted depending on your specific problem and desired accuracy. Next is set the max iteration. In this example, we have 1000. Next is call the fixed point iteration within the chosen initial guess, which is 1.0, epsilon, which is 0.001, the max iteration, which is 1000. The program returns 0 to indicate a successful execution. This code uses the fixed point iteration method to find the approximate root of a function by repeatedly applying the transformation x is equal to g of x until it converges to a solution or until the maximum number of iterations is reached.